In the summer of 1977, in a quiet field outside a small town in Ohio, there stood a machine the size of 3 football fields. It didn't look like much. No dish curving toward the heavens, no rotating arm tracking across the sky. Just a flat, silver structure lying nearly still, tilted only slightly toward the stars. People driving past on the nearby road might have mistaken it for some strange piece of farm equipment, abandoned and rusting in the grass. They would have been wrong. This was Big Ear, one of the most ambitious listening devices ever built by human hands. And on one particular night, it was about to hear something that, to this day, no one can fully explain. Big Ear belonged to Ohio State University, and it had been built for an entirely different purpose than the one that would eventually make it famous. Through most of its life, it scanned the sky for radio sources, quasars, galaxies, the faint background hum of the universe doing what the universe does. It was patient, methodical work. The telescope didn't move on command. Instead, it stayed fixed and let the rotation of the Earth carry the sky past its receivers, the way a person might sit still on a porch and let the world drift by rather than chasing after it themselves. By the 1970s, the project had shifted its focus. Big Ear was no longer just cataloging distant galaxies. It had become part of something stranger and far more speculative, a search for intelligent life beyond Earth. The program had a name, SETI, the Search for Extraterrestrial Intelligence. And despite how it might sound in hindsight, this was real, funded, peer-reviewed science. Astronomers reasoned that if another civilization out there wanted to be found, or even if they didn't, they might still leak radio signals into space, the same way humanity had been doing since the early 20th century. All you'd have to do is listen in the right place, at the right frequency, for long enough. The trouble was, the universe is loud in unhelpful ways and quiet in unhelpful ways all at once. Stars hiss. Galaxies hum. Background radiation fills every channel with static, a kind of cosmic white noise. Somewhere in that noise, if SETI's premise was right, there might be a signal that didn't belong, something narrow, something deliberate, something that looked less like nature and more like a message. The work of actually finding such a thing fell to a small, dedicated, and mostly volunteer-run team. There was no glamour in it. Each day, the telescope produced printouts, long ribbons of paper covered in columns of numbers, each column a frequency channel, each row a few seconds of listening. Someone had to look at this paper by hand, page after page, day after day, scanning for any pattern that stood out from the noise. It was tedious in a way that's almost hard to imagine now, in an era when computers do this kind of pattern recognition instantly. In 1977, it was a human job, done with a pen and a trained eye. One of the volunteers responsible for this work was an astronomer named Jerry Emin. He wasn't searching for fame. He was searching, quite literally, for noise that didn't behave like noise. Most days, that's exactly what he found. Nothing. The printouts came in, were reviewed, and were filed away, unremarkable. On the night of August 15, 1977, Big Ear was listening, as it always did, to a stretch of sky near the constellation Sagittarius, a region rich with stars, and not far from a dense, ancient cluster of stars called M55. The telescope had no idea anything unusual was about to happen. It simply did what it always did. It listened, and it recorded, second by second, as the sky swept past. For exactly 72 seconds, something was different. 72 seconds doesn't sound like very long. It's about the time it takes to boil an egg partway, or to wait through a long red light. But for Big Ear, 72 seconds was significant. It was the exact length of time that any single point in the sky stayed within view of the telescope's beam as the Earth rotated beneath it. That number wasn't arbitrary. It was a kind of built-in stopwatch, baked into the geometry of how the instrument worked. Whatever Big Ear detected during that window had to come from a single, specific point in the sky, and it had to rise and fall in intensity in a very particular way, growing stronger as it entered the beam, peaking in the middle, and fading as it left. Anything that didn't follow that exact shape probably wasn't coming from deep space at all. What the telescope recorded on August 15 followed that shape almost perfectly. The signal arrived at a frequency very close to 1420 MHz, a number that might mean nothing to most people, but means quite a lot to anyone working in SETI. That frequency sits right at what astronomers call the hydrogen line, the natural frequency at which hydrogen atoms, the most abundant element in the universe, emit a faint signature of radiation. Because hydrogen is everywhere, and because this frequency is so fundamental to the physics of the universe, many SETI researchers had long proposed that any civilization trying to get noticed might choose to transmit near this exact frequency, a kind of cosmic common ground, a channel every advanced society might think to check, simply because the physics of hydrogen is the same everywhere. And there it was. Right in that neighborhood. Rising out of the static. What made it even harder to dismiss was the strength of the signal. It wasn't a faint blip, easily mistaken for instrument error. It was roughly 30 times stronger than the background noise the telescope normally picked up, loud by radio astronomy standards, almost startlingly so. A weak signal can be explained away in a dozen mundane ways. A signal 30 times louder than anything else in the data demands an explanation. The telescope, of course, understood none of this. It simply recorded the numbers, printed them onto paper, and moved on to the next sweep of sky, the next few seconds, the next stretch of cosmic silence. The printout containing this anomaly sat in a stack with hundreds of others, page after page of numbers, almost all of it noise, almost all of it forgettable. It would take 3 days before anyone noticed what had happened. 3 days during which the signal had already come and gone, already become unreachable, already slipped past the only instrument capable of confirming it was real. 3 days during which the universe, if it had indeed tried to say something, had already gone silent again, and no one on Earth yet knew enough to even think to listen back. This delay matters more than it might seem to. In the decades of debate that followed, this 3-day gap between detection and discovery has often been treated as a kind of original sin of the whole event, the single biggest reason this moment in history slipped through humanity's fingers instead of becoming an answered question. If someone had been watching live, monitoring the data in real time, they might have redirected attention immediately, alerted other observatories, tried to confirm the signal again before it potentially vanished for good. Instead, the data simply waited, stacked in a pile. Unremarkable until it wasn't. When Jerry Emin finally sat down to review the printout from August 15th, he was doing what he did most days, working through stacks of paper, scanning columns of numbers for anything that broke the pattern of ordinary background noise. The work demanded a strange kind of patience, the ability to stay alert through hour after hour of nothing, because the one time something mattered, you needed to catch it. The big ear data wasn't recorded as a simple number scale. Signal intensity was represented using a system that converted strength into characters, numbers for weaker readings, and letters for anything strong enough to exceed what a single digit could represent. The stronger the signal, the further up the alphabet the character went. Most printouts, across most nights, showed mainly low numbers, the quiet hum of a calm universe. But on this page, in a single sequence of readings tracking the rise and fall of one continuous signal, Emin found something he hadn't seen before, a string of characters reading 6EQUJ5. To understand why that sequence stopped him, you have to understand what those letters meant. Each one represented a stronger reading than the last digit could express. The letter U, sitting near the peak of that sequence, represented one of the strongest readings the system was capable of recording, a signal intensity far beyond anything typically seen in this kind of survey. The shape of the sequence itself, rising, peaking, falling, matched almost exactly what astronomers expected a real, fixed celestial source to look like as it passed through the telescope's beam. This wasn't noise behaving randomly. This was a signal behaving like an actual, located point in space. Emin picked up a red pen. He circled the sequence on the printout. And in the margin, next to that small string of letters and numbers that represented 72 seconds from 3 days earlier, he wrote a single word, wow. It wasn't poetic. It wasn't a scientific term. It was the spontaneous reaction of someone who had spent countless hours staring at unremarkable data, suddenly looking at something that didn't fit any of the explanations he was used to ruling things out with. That handwritten word, almost an afterthought, would go on to name one of the most famous unsolved mysteries in the history of astronomy. Word of the discovery spread through the small SETI community quickly, but quietly. This wasn't the kind of story that made headline news overnight. There was no press conference, no dramatic announcement. It was, at first, simply an anomaly, a strange, strong signal, recorded once, never confirmed, sitting on a single sheet of paper. Astronomers are trained to be skeptical of exactly this kind of event. One detection, with no repeat, no second observatory confirming it, no way to triangulate or verify. By every normal scientific standard, this should have been impossible to draw any real conclusion from. And yet, the characteristics lined up too well to ignore. The frequency, sitting almost exactly on the hydrogen line. The shape of the signal, matching the predicted rise and fall of a fixed point in the sky passing through a fixed beam. The strength, far beyond ordinary background noise. Every individual piece looked like exactly what astronomers had spent years describing as the signature they were hoping to find. If this was a mistake, it was a mistake that happened to look exactly like the discovery everyone in the room had been searching for. So the question shifted from, "What is this?" to a much more practical one. Could they find it again? The search for a second wow signal began almost as soon as the first one's significance became clear, and in some sense, it has never really stopped. Big Ear itself was pointed back toward that same patch of sky in Sagittarius, again and again, in the weeks and months following the discovery. If the signal had come from something fixed, a transmitter, a beacon, anything with a stable location, there should have been a reasonable chance of catching it again, especially with repeated observation of the exact coordinates. Nothing came back. This in itself wasn't necessarily damning. A transmitter, if that's what it was, might not broadcast continuously. It could have been a brief, deliberate pulse, or part of some kind of rotating beam sweeping across the galaxy rather than aimed permanently at any one point, meaning Earth might have simply been in the right place at the right moment once, with no guarantee of ever being there again. But the lack of any repeat signal also opened the door to other, more mundane possibilities. Equipment malfunction, a satellite passing briefly through view, terrestrial interference accidentally mimicking the signature of a deep space source. Over the following decades, other researchers picked up where Big Ear left off. Astronomers including Robert Gray and Simon Ellingson conducted their own dedicated searches using different telescopes, hoping that more sensitive, more modern instruments might succeed where the original observatory had failed. These efforts spanned years, sometimes using telescopes far more powerful than Big Ear had ever been. The results were consistent in their inconsistency, nothing matching the wow signal's specific characteristics ever reappeared. Big Ear itself didn't survive to see most of this later research play out. By 1998, the observatory had been decommissioned, the funding gone, the equipment outdated, the land it sat on more valuable, in the eyes of whoever made that decision, as something else entirely. The structure was demolished. In one of the more quietly strange footnotes in the history of science, the site where humanity's most famous unconfirmed brush with a possible alien signal was recorded was eventually redeveloped, in part, into a golf course. For years, there were real fears that even the original data from that night might be lost entirely, that the only physical record of the wow signal could simply vanish along with the institution that had produced it. The Ohio SETI project had operated largely on volunteer effort, without the kind of dedicated, long-term archival infrastructure that better-funded scientific programs might have had. It was only through the efforts of those same volunteers, determined to preserve what they had recorded, that most of the original data survived at all. So the search continued, not just for a second signal, but increasingly for a better understanding of the first one. As technology improved, researchers began going back through old archives, not just Big Ear's, but other observatories' records from the same era, looking for anything that might shed new light on what had actually happened that night in 1977. It was in this more recent wave of investigation, decades after the original detection that the most serious scientific challenge yet to the signal's mystery would emerge. For nearly 50 years, the WOW signal sat in a strange, unresolved middle ground. Too strong, too clean, too consistent with the predicted signature of an artificial transmission to dismiss outright. But too brief, too unconfirmed, too singular an event to ever be proven as anything more than an intriguing anomaly. Two broad camps formed around it. One held on to the possibility, however small, that this had been a genuine signal from another civilization, not necessarily proof of aliens, but proof of something. Proof that, even once, something out there had produced a signal indistinguishable from what scientists had spent decades hoping to detect. The other camp searched for a natural explanation, something in the universe capable of producing a signal that merely looked artificial, without anyone, or anything, sending it on purpose. Various natural explanations were proposed over the years. Comets, with their surrounding clouds of hydrogen gas, were one early candidate, since a sufficiently dense hydrogen cloud passing through the telescope's field of view might theoretically produce a narrowband signal near the hydrogen line. Some researchers proposed that a comet's hydrogen envelope, interacting with solar radiation in just the right way, could account for the signature. But more recent, more rigorous research has pointed toward something else entirely, the possibility that the WOW signal originated from a rare and poorly understood astrophysical event involving clouds of cold, neutral hydrogen scattered throughout interstellar space. A team led by researcher Abel Mendez, examining archival data from a different observatory, found other signals with broadly similar characteristics to the WOW signal, fainter, but following a comparable signature. Their proposed explanation involves something called superradiance, a process in which a cloud of hydrogen gas, illuminated by an external source of radiation, could in theory shine far more brightly at this exact frequency than it normally would, briefly mimicking the kind of strong, narrowband signal that astronomers had long assumed could only come from artificial transmission. If correct, this would mean Big Ear hadn't picked up a transmission from anyone, but had instead caught an extraordinarily rare natural event, a cloud of gas, lit up by chance, in exactly the right place, at exactly the right moment, to produce a signal capable of fooling nearly 50 years of scientific speculation. This explanation is compelling. It's grounded in real astrophysics, supported by similar signals detected in other archival data, and consistent with known properties of interstellar hydrogen clouds. But it is not, even now, definitively proven. The exact conditions required to produce a signal as strong as the original WOW signal through this process remain at the edge of what scientists fully understand. No one has caught this exact kind of natural event red-handed, the way Emin caught his anomaly on a printout in 1977. So the mystery persists, not because there's no plausible explanation, but because no explanation, natural or otherwise, has been confirmed beyond reasonable doubt. The WOW signal remains exactly what it has always been, a single, unrepeated, 72-second anomaly sitting at the exact intersection of almost certainly natural and we genuinely cannot rule out the alternative. For a search built entirely around the hope of finding exactly one undeniable signal, that's either the most frustrating possible outcome or the most tantalizing one. Nearly 50 years later, the WOW signal remains the single most famous unresolved event in the entire history of the search for extraterrestrial intelligence. Not because it's the strongest evidence ever found, by most rigorous scientific standards, a single, unconfirmed detection is weak evidence at best, but because of what it represents, the closest the search has ever come to catching something that genuinely couldn't be immediately explained away. Every SETI program since has, in some sense, been chasing the shadow of that night in Ohio. Newer, more sensitive instruments, wider surveys, faster data processing, capable of flagging anomalies in real time instead of waiting 3 days for a volunteer to notice them by hand. In many ways, the entire infrastructure of modern radio SETI research exists partly as an answer to the WOW signal's central frustration. If it happens again, we don't want to miss it a second time. The site where Big Ear once stood is unrecognizable now. The football field-sized structure that once listened patiently to the rotating sky is gone, replaced by ordinary, manicured ground, a quiet, almost absurd ending for a place that, for one night in 1977, may have been the closest point of contact humanity has ever had with something not of this earth. There's no monument there, no plaque marking the spot, just grass and the occasional golfer, entirely unaware of what the ground beneath them once helped record. And maybe that's fitting in its own strange way. The wow signal was never really about the place. It was about 72 seconds, a strip of paper, and one handwritten word that, decades later, we still can't fully explain. Was it a message? Was it a hydrogen cloud lit up by chance, in exactly the right place at exactly the right time? The honest answer is that we don't know, not with certainty, not even now. What we do know is that for 72 seconds in August of 1977, something out there matched, almost perfectly, the exact signature humanity had spent years hoping to find. It happened once. It has never happened again. And somewhere, on a quiet night, another telescope is still listening, just in case it does.